We are lost in an obscure backwater of space and time, a small planet that goes around one of 400 billion other stars, located on the periphery of a minor spiral arm of one of 100 billion other galaxies. That's the fact. That's where we are. And if we find that daunting, then it's time to work on our daunting machinery, not to ignore the universe.
Hubble is an incredibly beautiful, it's an aesthetic kind of spaceship. I mean, it is magnificent. You understand you are a threat out there, your very presence. Rubbing and touching anything produce contamination by definition. You flake little things off, dust off. You try not to touch anything. We were trying to turn work into art. Just how good a craftsman can you be? Working out there is working with a really bulky glove. It's working with a suit that weighs 500 pounds, and you're dealing with screws 2 or 3 millimeters in size that were non-captive, because in zero-G, everything is free, and you'll just watch these screws. They do their little dance. Every time you touch one of those things, you impart energy, and it starts a dance. Dance of the spheres.
I remember waking up at 2 or 3 o'clock in the morning and turning on the television, seeing Story hanging out on the edge of the Hubble with Australia up under him. It's probably one of those one-in-a-lifetime things. When I get to be an old guy, I can see myself with my grandkids on my knee telling them about. Remember that big telescope up there? I helped train astronauts to fix that.
Now, Hubble's the most powerful instrument in terms of looking at the universe that we have ever had. Now, that's why Hubble touches people, but not only as a literal, physical, scientific instrument, it is a symbol for humanity's quest. What is our place in the universe? What is our universe?
If anything, I think NASA has failed to communicate how really complicated it is to do spaceflight. It's certainly not American Airlines running on some timetable to New York. And as a matter of fact, it's an enormous challenge to get one of these things off the ground. I'm always amazed that it works at all, you know, and that's from being inside of it.
So we're going to have to pull the line back out. The alignment didn't make it, so
yeah,
pull the line back out.
-1Y.
The shuttle main engines are high-performance engines operated at 104% of their design capabilities, and so we're having to look at the turbo pumps and pieces of the engine after each mission and often replace them.
Right there, that's what I'm thinking of what we're seeing.
The aft compartment of the shuttle is kind of like a maze. I refer to it as a space-rated Swiss Family Robinson's treehouse. The paradoxes there are unbelievable. You have a titanium thrust structure that holds thousands and thousands and thousands of pounds of thrust. Right next to it, you have a phenomenal amount of plumbing and wiring, and it's all very sensitive and very delicate. imagine being back here during a orbital liftoff. You've got gallons and thousands of gallons of liquid oxygen flowing through this feed line, and it's coming from the external tank disconnect located down there. Everything that we do down here has to be perfect, because when you go into orbit, there's no way of getting back there and working on anything.
I thought, well, the shuttle will just be another easy system. You know, within a matter of weeks, a couple weeks after getting the books on it, I'll study it up and I'll be ready to go fly it. And it turned out to be not the case.
The aircraft is a highly modified Gulfstream II. Flies almost exactly like the Space Shuttle. The performance has been modified so it descends like the Space Shuttle. The same descent rate, the same type of drag. It's very, very important training for shuttle pilots because the shuttle is a very difficult aircraft to fly, and it's very different from any other airplane that I've flown in my life.
We have an instructor pilot in the right seat who gets the airplane up to about 35,000 feet. And at that point, we put the engines into reverse, and you're rapidly on your way down to Earth at the rate of 22,000 feet a minute.
Commercial airlines, you come in at about a 2% glide angle coming down. Shuttle comes in 22%. That's going downhill real fast.
In order to model the touchdown eye height of the space shuttle, the pilot has to be some 33 feet in the air. Well, that puts the G2's wheels still 20 feet off the ground.
Before you fly as a commander, you typically have about 1,000 approaches. And you get about 10 a flight, so about 100 flights in the shuttle training aircraft.
It's a real nice process coming back. When you hit the Earth's atmosphere, you're doing Mach 25 or about 18,000 miles an hour. And the way you slow down is by pancaking or sort of speed braking the orbiter into the Earth's atmosphere. And that's why the tile are so critical on the bottom, is that they absorb that heat.
5, 6, 7, 8, 9, 10, 11. Okay, that's it.
Lower surface tiles can protect up to 2,500 degrees. It is sometimes hard to believe that it protects it like it does. It's strictly real thin aluminum underneath, that's all it is.
113, 115, 106.
It's a giant jigsaw puzzle that has 35,000 different shapes and sizes of tiles.
Next row. 12.